Good afternoon, everyone. I'm Harry, the co-founder and CEO of CTOR Lab, and today I'm going to talk about 3D Composable NFT, a new dimension in digital collectibles. And my speech is divided into three parts. Firstly, I will talk about, I will provide a comprehensive definition of dynamic NFTs, and secondly, I will delve into the experience of building it, and lastly, I will talk about the challenge we faces along the way and why we believe dynamic NFTs are the future. Okay, next page. Yeah, so what exactly is a dynamic NFT? So there are two most common definitions. The first one is that if a metadata of an NFT is updated automatically based on the logic of a smart contract, it is a dynamic NFT. So for example, if a NFT's description is different, if they are in different wallet, or the traits get upgraded if the holder completes certain tasks, or if the images of an NFT changes over time. So there's a very well-known project called OG Crystal. I don't know if anyone heard it. So it is a well-known dynamic NFT collection. It is a crystal. It will grow whenever there is a token transfer from a wallet to another wallet. It will grow, and its shapes and its color will change based on the collection in holder's wallet. So if you have a BAYC or you have a Clone X, then your crystal will grow differently. So that's pretty cool. And then the second definition of dynamic NFT is that it is an interactive 3D model. It is playable, interactive, so rather than a still image or a static video. So our recent project is called Elysian Shell Next Manga. So if everyone is interested, just open that link. So it is a 3D model, like you can see in the picture. It can put into every metaverse or game engine. So as you can see, we can rotate the model and we can see it from any angle, and we can dictate its movement. And for example, in this case, we made him to make a fly kick move. So yeah, and the holder of the NFT can just download the 3D model and put it into metaverse or game engine, and it can also just make again out of this model. This 3D model assembly, like as I mentioned, like this project, this collection is a robot collection which is like assembled from a component and NFT collection. There's a separate collection called Elysian Shell Next Manga Component collection. So user can buy whatever component they want, like a head, a body, legs, and equipment to assemble a robot. So this assembly part is divided into two sections, two phases. Like the first phase is on-chain components assembly. So basically, user need to go to OpenSea and choose a component they like. I like the invader head. I like a guardian body. I like a gun equipment, and then choose the components and burn it on-chain. So then I will know, oh, smart contract will know, oh, you burn this head, you burn this body, and you want to compose all these components into a robot. So I made an on-chain event from smart contracts, and then our monitor program will detect these events and send the assemble request to our own customized backend. Then the second part is the off-chain 3D model synthesis, because our NFT need to be generated on demand. Whenever the user want to generate a robot, then we generate the 3D model on demand. So we need to interpret the assemble request and generate 3D model on demand with our own customized Unity program, and then upload the generated 3D models to IPFS, a decentralized storage. So basically, at this moment, every NFT project, their go-to implementation is a smart contract called ERC 721A. like developed by Azuki, if anyone knows. So, but while we are developing this project, since we have a requirements that the user need to burn multiple NFTs, right? They need to choose their components, the head, the arms, the legs, the body. So like whenever they want to assemble a robot, they need to burn at least five components. But in terms of burning multiple NFT, ERC 721A is very poor. Like it has poor gas efficiency in terms of burning multiple NFTs. So here at Setor Lab, we developed a whole new NFT smart contract called ERC 115 Delta to solve our problem. So it saves 87% gas comparing to ERC 721A. And it is the only implementation that can satisfy all our requirements, including like fixed gas usage in batch milling, fixed gas usage in transfer, and gas refund from burning tokens. And if anyone is interested, just go to erc1155delta.ctor.xyz. That's the official site that you can check more details. Okay, so while we're building this project, the project shown the potential of the dynamic NFT. So we believe this is the future. So like if we take a look into the like the traditional web history, like the social media, like we came from a just blogging, and then we just post text and images on Facebook and Instagram. Then right now everybody is uploading short videos on TikTok. So for NFT, we think it is the same trend. Like we must evolve from static to dynamic. We don't just want like image. Image can show on paper too, right? Why do I need the computer? Why do I need a blockchain, right? So that's why we think it is inevitable. So the second reason why we believe it's the future is like GameFi, because we think GameFi will play a significant role in mass adoption of NFT, right? So the dynamic NFT like upgradable character or consumable potions or equipments that can be merged or destroyed, it's essential. So, and another exciting like the new prospect of dynamic NFT is the real world assets. Like for example, if you issue an NFT for a house, a property, then the metadata can be its ages, its maintenance history, its past sales. Then you can have this decentralized certificate of this property that will change over time, and all this data will be accessible transparently. So these are the reasons why we believe dynamic NFT is the future. However, there are still some challenges we face as we develop dynamic NFTs. So, like the first one is that in order for the metadata to be updatable, to be dynamic, there must be a certain degree of centralization for triggering the metadata update. So, for example, in the house NFT cases, who's gonna change the metadata to say that the past sale is 1 mil or 2 mil? Like there must need a kind of centralized party to set that update. So, and then the second part is that like right now, lots of NFT projects are store metadata on IPFS, a decentralized storage way of storage. So when you upload metadata to IPFS, then it's immutable. So it leads to the second challenges is that if we want to make the metadata mutable, right, because we want to update the metadata, then how can the NFT holders trust that this project's owner will not rock me, right? Because they can change the metadata on their will. So that's the second challenge. And the third one is cost. If we want to build a project like, as I mentioned before, Elysian, the 3D model project is cool robots, then it will take massive efforts due to you need 3D artists to spend a lot of time and money to build sophisticated 3D models. That's not an easy task. Okay. Oh, okay. Sorry. Okay. So yeah, I think that's it. And thank you for your attention. So feel free to ask me any question about anime NFTs through Twitter or our official website. And make sure don't miss our amazing talk from our CTO, Gilbert. He will talk about more about ERC 115 by Delta, ultra gas efficient NFT smart contracts. So thank you again. Thank you.